Alrighty, so this is lesson 4 in chapter 1 for IM1, and this is all about the distributive property. So first, we want to look at the distributive property and what that means. So you can look at your textbook for the word meaning here. So this is the definition from the textbook, and instead of writing out the whole thing, let's go ahead and read it here. Because if I try to write all that with my pen tool, although I'm getting better at it, it doesn't come out super duper neat. It's not quite the same as writing on paper. So for any numbers A, B, and C, we have A times B plus C in parentheses, and this equals A times B plus A times C. And then you can do the same thing where A is on the other side. It would do the exact same thing. Now you just have BA plus CA. So this idea is, what we're doing is we're multiplying. So when we have parentheses like this, and I'm going to drop this guy down so that I can actually write in here. So we have A times B plus C. I actually want to kind of show you that. So they're multiplying. They're taking this A and they're multiplying by B. That's where they got AB. Plus, they're doing A times C, so AC. And when they did it the other way, so they had B plus C with A on the other side, it doesn't matter. You do the same thing. You still take A and you multiply it by the B. And I can actually write this as AB again. Or I can write it as BA. It doesn't matter which way I write that. Multiplication is commutative in that way where you can flip it around. So it really doesn't matter if I say A times B or B times A. I'm still multiplying the same two numbers. Plus, and I would do the same thing, A times C. So they wrote CA. Again, you could write AC. It doesn't matter. Remember, it just means you're multiplying those two numbers together. So this actually does throw students for a loop sometimes when they're used to seeing it on the front here like this, and then all of a sudden they get it on the end, and they kind of stop and go, oh, wait, that doesn't look like what we did in class. So it is kind of nice that we're bringing up both examples here where you can see it doesn't matter if it's on the front or if it's on the end. You're still multiplying it the same way. You're going to take that number or that letter, that variable, you're going to multiply by everything inside the parentheses. All right, let's look at like terms. So what are like terms? And again, if we go back over here, so like terms are terms that contain the same variable with corresponding variables having the same power. Okay, what does that mean? So they have the same variable, meaning A plus, I'm going to go 2A. So these are the same variable. That's fine. I can actually combine these guys because I have 1A. Remember, if I don't see a number here, it means 1. 1A plus 2A, I have 3 A's. But what if I change this and I said it was A squared plus 2A? Okay, this is where they become not like terms. Even though I have the same variable, they're both A. One is raised to the second power. There's multiplication happening here. So this is actually an order of operations issue. I can't add these two pieces before I've multiplied, because remember, that's what exponents mean. So that's why you can't add the same variables that have different exponents. It breaks the order of operation. We have to do the multiplication before we can do the addition. So we have to make sure that they are the same variable and they have the same power. So either no power at all, like this, or they both had the same power. So they can both be raised to the power of 2. Now I can add them. That's perfectly fine because I can add them and then multiply after since they have the same power. It's actually not going to change the problem. But if they don't have the same power, I can't do that. I have to deal with the power first and then I can do the addition. And this can be as simple as, regular numbers also, and I call them regular numbers, but it's constants. So if I have, 3 and 5, okay, these are like terms. They're just regular old numbers, no variables attached at all. So I can say 3 plus 5 is 8. I can combine them. But if I go A and B, all right, now they're not like terms, and I always like to associate, like maybe this is apples and bananas. All right, well, I can't add them together. They're different things. They're different numbers. I need to know what they are first. And again, this has to do with order of operations. I have to do this multiplication before I can do the addition, because multiplication comes before addition in order of operations. So that's the reason why we can't add unlike terms. It literally has to do with order of operations. All right, so let's go ahead and practice. First, we're going to practice the distributive property, and then we're going to practice some like terms down below. So this first one here, we have our number on the right side. It's all the way on the right side. And again, I know that sometimes throws students off, like I was talking about up here, but it doesn't matter if the 2 is on the front or if the 2 is on the end. It doesn't matter what position it's on. You're going to take that 2 and you're going to start multiplying by everything in the parentheses. So we have 8 times 2. We get 16. And then we have 4n times 2. And there's a plus sign here, so I want to go plus. 4 times 2 gives me 8. And then I don't want to forget the n because the n was there. We have to bring the n with that 4, which became 8 because I multiplied by 2. So this is our answer. That's all we're looking for. We're just simplifying the expression so that we don't have parentheses anymore. All right, let's take a look at this one. So we have -4 this time. So we have -4 times -8. Anytime we have 2 negatives, we're going to end up with a positive. So we know our answer is going to be positive since they're both negative here. So we can just focus on 4 times 8. So we have 32. And then we have -4 times -3m. So again, negative. So I know it's going to be positive. So now I can just focus on 4 times 3. So I get 12. And we have to make sure we bring the m over there with it. And I forgot the little arrow here. Whoop, boop, boop. So we multiplied by -4 there. All right, let's take a look at the like terms down below here. So simplify each expression. If not possible, write simplified. So we have 6n minus 4n. So they both have an n, the same variable, and neither one has an exponent, which actually means it's an exponent of 1 when you don't see it. A lot of the time when we don't see things, it tends to be a 1. So this just means we have 6 n's and we're taking 4 of them away. So same thing if I were to write this out, n, 1, 2, 3, 4. There's 6. And then I'm going to take 4 of them away. So I can do that visually. I have 2n. Or I can just do the math here and go 6 minus 4. That gives me 2. So I need to make sure I bring the n with it. They both have an n, 2n. All right, so let's take a look at number 4 here. We have b squared plus 13b plus 13. So they're definitely trying to be tricky here. We have a b and we have a b. One has an exponent and the other does not. We cannot add these two guys together because order of operations says I need to deal with this multiplication, because remember that means b times b, before I could add it to 13b. Ooh, excuse me. Excuse me again. So they also are trying to be tricky with these 13s. Since they're matching, I think that's why they did 13 and 13. It looks like they are like terms since they're the same number. But one has a variable and one does not. So one is being multiplied, 13 times b, and one is just 13. So again, order of operations says I cannot add these together. I have to do this multiplication before I could add the 13 to it. So this guy is simplified. All right. So you're going to go on to Alex and you're going to complete the homework assignment associated with this lesson. You can refer back to this video. It will still be on Google Classroom there for you to refer back to. And I will see you in section 5. All right.